Today's question: a student is performing the experiment of a resonance column. The diameter of the column tube is 4 cm. The frequency of the tuning fork is 512 Hz. The air temperature is 38 degrees centigrade, in which the speed of the sound is 336 meter per second. The zero of the meter scale coincides with the top end of the resonance column tube. When the first resonance occurs, the reading of the water level in the column is. So this question is quite straightforward with a minor, we can say, modification or trick. That is, here the diameter of the tube is given as 4 cm, and because of this 4 cm, or rather we can say diameter of the column, a term that is called end correction will be introduced in the formula for calculating the, you can say, effective length of the closed tube. Normal length of the closed tube, because it is resonance column, so resonance column is closed from one end and is open from the other end, and it's for first resonance. It is said in the question that the length of that resonance column for first resonance is lambda by 4. But because of the end correction, which is represented as E, the total length now will be equal to L plus E, where E is dependent on the diameter as 0.3 times the diameter. So this is the only change that will be introduced because of this diameter. So let us start from the basic formula, which states that for resonance in a closed tube, the length of air column, or we can say here it is the water level of the column. Okay, the length of water column for first resonance will be given as L is equal to lambda by 4, where lambda is the wavelength of the sound. Wavelength of sound. Now we come to the next part, that is trick that is given the question, is that for diameter D. So we say to compensate, we can say to account for end diameter, let us call that as small d of the tube, the effective length we can call that as LE, will be equal to length plus plus E, where this E, it is called as end correction, given as 0.3 times the diameter, and the diameter is given to us, so we just calculate that E will be equal to 0.3 multiplied by 0.04, and this comes as 0.012 meters. Now we can also find out the wavelength by using the basic formula. We can say our wavelength lambda will be equal to velocity divided by frequency. Velocity is given as 336, frequency is given as 512 Hertz, and this comes as approximately 656 meters. Now it is a simple calculations. So we can say the effective length of air column of, in this case, water column, which is our L. Sorry, let me write it. The length of the water column. The length of water column L for first resonance will be our L plus E is equal to lambda by 4, and we just calculate our lambda. Lambda was our 0.656 divided by 4, which is approximately equal to 0.164, and we also know our E, so we get our L is equal to 0.164 minus E, and substituting value of E, 0.164 minus 0.012, and this gives us 0.152 meters, and the options that are given to us are in centimeters. Therefore we can write that our length L will be equal to 15.2 centimeters. So if you check the options that are available to us, option number B is the correct option. Option B is correct. So this question was quite simple. The minor thing involved in this is our value of end correction because of the diameter that is given to us. So this completes the question. Thank you.